Now let us discuss the interpolation for the equal intervals. For the equal intervals, we have many types of the interpolations, but we will study here only Newton's forward and the Newton's backward interpolation. Otherwise, we have Stirling formula, binomial formula, or Bessel's formula for solving the interpolations. Now, let us see the Newton's forward interpolation. It is for equal intervals. It is for equal intervals. Here, first of all, we see the formula for the forward interpolation, that is delta x or f of x is equal to, say, f of x is equal to y0 plus p times delta y0 plus p into p minus 1 divided by 2 factorial into delta 2 y0 delta 1. It does not mean square. Here we denote it by double dash. P into p minus 1 into p minus 2 divided by 3 factorial into delta 3 y0 plus p into p minus 1 p minus 2 p minus 3 divided by 4 factorial into delta 4 y0 plus so on. We can extend or reduce the formula according to the given data. Here p is any constant. What is the value of p? P is equal to x minus x0 divided by h. Who is x? X is the point of interpolation, and x0, it is the point from where the data begins, or we can say it is the initial point of the data, and h is the height of the given data. Because here the height remains the same, so we can use the concept of the height. If it is not same, we cannot use this formula. P is equal to x minus x0, and most important condition for here P is, say, P must strictly lies between 0 and 1. That is very important condition when we apply the formula. How we will check it? We see it in later on during the calculations. But remember, the value of P in the forward interpolation, that must be between 0 and 1 strictly. It means greater than 0, less than 1, but 0 and 1 are not included. Let us consider an example, simple, say, for the given data x, 10, 20, 30, 40, 50 and y, it is 46, 66, 81, 93, 101. Evaluate. It's the simple formation. Evaluate F15. F15, who is 15? Here no, 15 is the point of interpolation. And these are the x and y's given. We see 10, 20, 30, 40, 50. Equal intervals. Height of the data is same. First of all, in both the cases of Newton's interpolation, rather it is forward or it is backward, first of all we construct a difference table. the method of constructing the difference table in both positions is equally same, but the difference is from where we select the values. Let us say we write this given data x and y in the vertical form, say like this: x 10, 20, 30, 40, 50, and y 46, 66, 81, 93, 101. It is the given data. The first of all we find delta 1 y0 or delta 1 y. What does it mean? See, what we have to do in y, we subtract the conjective values preceding with previous, that is 66 minus 46, and we write here in front of it, that is equal to 20. Then 81 minus 66, that is equal to 15. 93 minus 81, that is equal to 12. And 101 minus 93, that is equal to 8. These values may also be negative or may also be positive. Whatever result we get, we write it in this way. Then we find for delta double dash y0. Now we find the difference of these two conjective terms. 15 minus 20, here we write it is minus 5. 12 minus 15, it is 3. 8 minus 12, it is minus 4. Then delta 3 y0, 3 minus minus 5, we write here 8, minus 4, minus 3, it is minus 7. Then delta 4 y0, that is minus 15. That's minus 15. It is minus 3, 8 minus 5 minus 8, that will become to 2. It is minus 1 and it is minus 3. We have to subtract from lower value and upper value. Either result is plus or minus. No, it is our difference table. First, it will be the same in the backward formation. How to decide the values for the formula? We see, first of all, we find now P. P is equal to x minus x0 divided by h. That is equal to, what is x? It is the point of interpolation, 15 minus. If we consider the first value, it is x0, and the second value as y0. 15 minus 10 divided by height of interval 10. Height of interval 10. 30 minus 40, 10. 40 minus 50, 10. That is equal to 0.5. And we know 0.5 lies between 0 and 1. It is very important to check either the point P lies between the given condition or not. If this value of the P doesn't obey this condition, then again we work for the value of P by taking the lower set, as the x0 and y0. If the value of P doesn't satisfy this condition, it means we cannot consider these values as x0 and y0, so we shift to the lower values, that is 20 and 66. and again we check. Again we check for the value of P. If it is satisfied, then okay. If it is not, then again we move below pair of the values. No, in this case, the value of the P is obeyed. That's now we consider the value. Now we have considered here up to 4.